Hello, in today's session we focus on data privacy and we want to utilize for our fictitious company Red Cycles different components in order to make the exchange of data more secure. Let's take a quick look at our agenda for the session. We will take a look at the requirement for data privacy and how we can utilize privacy guard components and platforms to accomplish this. How does a basic setup look like and how can we implement this properly to let Control M drive the automation in the back end, and take a look behind the scenes in regards to troubleshooting and the implementation of that. So let's start off with the requirement that Red Cycles has. Red Cycle focuses on product innovation, time to market and time to value. And that means that there's continual change and demand for speed. Everything from product design to manufacturing to supplier networks and all the other distribution channels, including marketing. All of these data-hungry applications are always changing. And to meet the need for speed and growth without adding operation staff, they're considering augmenting their purely centralized platform in a way that authorized end users can perform certain operations and satisfy their needs on demand. However, we need to accomplish this in a governed manner so that compliance is adhered to, as well as that we have consistent execution. Only in this way can we really scale. So the sales and the external marketing agency need to exchange data in a secure fashion. Not only to transmit the data in a secure fashion, but when the data is at rest, we want to have it secure as well. So what Red Cycles really need is pretty good privacy. I meant to say pretty good privacy. How can we accomplish this? Well, we need to have some means to secure the data. And how can we accomplish this? Well, by means of encrypting the content that we have, and on the other side, decrypting the content. So both parties that are involved have access to the data, but nobody in between. And we utilize here GNU Privacy Guard, or the commercial version PGP, for asymmetric encryption. GPG is a free and open source encryption tool designed to ensure the confidentiality, integrity, and authenticity of digital data. Its purpose is to provide secure communication and data protection by allowing users to encrypt sensitive information with the public key and decrypt it on the other side with the private key. GPG is widely used for email encryption, digital signatures, and secure file sharing, helping individuals and organizations safeguard their privacy, verify the authenticity of messages, and protect against unauthorized access or tampering of the data, so that the data is really transmitted in a secure fashion, as we are living in a much more interconnected digital world. Using Privacy Guard or GPG in connection with managed file transfer can offer several valuable benefits, driven by the need for secure and confidential data exchange. For example, data in confidentiality, data integrity, compliance, non-repudiation, or secure automation, just to mention a few. So let's see how this works on a conceptual basis. Asymmetric encryption uses two separate keys, a public key and a private key. Often a public key is used to encrypt the data, while the private key is used to decrypt the data. And as you can see here in the animation, we have now content in plain text. The public key is used to encrypt the content, and what we end up is to have a ciphertext, text that nobody can read and understand. The recipient, on the other hand, needs to reverse the process and decrypt the content by utilizing the private key when this process is taking place, and at the end will have access to the plain text. So you can see here from the left to the right a process that is being executed utilizing the private and the public key. In order to better understand how this affects Control M, let's take a look on what GPG really contains, what kind of capabilities as well as component are involved with that. So first off, we start off with the key ring. We have a key ring system. A GPG uses key rings to manage keys. A key ring is a collection of public and private keys organized in keyring files. Common key rings include the pubring.kbx for all the public keys and secring.gpg for all the secret keys. Next, we have a key pairs and key pair files. A GPG relies on a pair of cryptographic keys, a public key and a private key. We see this on the right-hand side. The public key is used for encryption and verifying signatures, while the private key is used for decryption and creating signature. So you can see here how they work hand in hand. Let's take a look at the public key. This is the key that you share with others. It is used by others to encrypt data that only you can decrypt with your private key. It's also used to verify signatures created with your private key, which leads us to the private key. The private key is kept secret and securely stored. Never share this with anybody. It's used for decrypting messages encrypted with your public key for creating digital signatures. Now, when we are taking a look at encrypting and decrypting, we also want to make sure that our keys are safe. So there comes a passphrase into play. A passphrase is a strong password that protects your private key. It's required to unlock your private key for decrypting and signing operations. It's not required to encrypt content. That's really important to keep in mind. Three more aspects we have here, which is the key ID. Each key pair has a unique key ID or key identifier that can be used to refer to a specific key. Key IDs are used when importing, exporting, or referencing keys. And then we have a key fingerprint. A fingerprint is a cryptographic hash of a key's public key data. It's a way to uniquely identify a key and verify its integrity. Now, with the key ID and the key fingerprint, we can do something very fantastic when it comes to automating the process between decrypting content and encrypting content, or the other way around, encrypting and decrypting, and handling that interaction between the multiple parties. And this will be covered in a subsequent video. So just keep that in mind, that our key ID and our key fingerprint is unique and can be used to identify which of my keys do I have here. But in order to really utilize these keys, the GPG platform needs to make sure that not everybody can bring here a key and work with the data. So we have a trust model in place. On the bottom left, you see here the trust model identified. GPG uses a trust model to determine the level of trust you have in other users' keys. Users can sign each other's key to indicate trust. And these trust levels include unknown, none, marginal, full, and ultimate. In our demo environment, we are using ultimate as our trust level for the key. So now that we have the basics of GPG and how they are being configured and everything that is involved, you need to keep in mind that this is tied to the operating system user. Really important, that is the OS user where you execute this command, which means for user A, you have a key ring system. For user B, you have a key ring system. Usually you don't want to mix around these key ring systems because they have the access to that confidential data or grant you access to confidential data. So you want to keep that in mind. From a Control M perspective, now we have certain areas as well that we need to cover and take a look on how this plays in. So in the top right hand side, you see how the key ring system is assigned to the individual user that corresponds in the connection profile to the run as account. So whatever you have in the run as account will be used to execute the GPG commands, and in this user's context we make sure that we have access to the key database and to the individual keys that we need to have for encryption and decryption. Which means if you are going to have multiple public keys, they are stored in your key database, then the connection profile, the user that you put in there, needs to have access to the proper system. Next would be the encryption and decryption phase. For the encryption phase, we know we want to encrypt the data, and so what we need here is the public key. We create a template for our agent so that the agent knows how do you want to utilize the GPG command line utilities, and which run as account is of course specified in our connection profile. So for encryption purposes, again, the agent needs to have access to the file system. Therefore, encryption of content that lies in public cloud storage or on an SFTP site, usually a problem because the OS system doesn't provide the file system access to encrypt the content. And therefore, you can only pick and choose the GPG operations for MFT job activities that are tied to a local file system. So you need to have a connection profile that points to the local file system. Now, if the OS provides the means under the cover to access remote file systems, that from an execution perspective, that is just fine, because the GPG utility doesn't need to figure out, is this now in the cloud, is this somewhere on a shared drive, or is this local? It doesn't know it because the OS will cover this under the cover. So keep that in mind, that only local file system can be utilized with that command. So that would be the encryption phase. Now we touched on a passphrase. Where does that come in? Well, if we are doing the decryption, which is extracting the content from our secure file that we have, we of course need to have a template that defines on what kind of parameters do I want to assign to that execution. But in addition to this, we also need to have the passphrase. The passphrase, remember, is the means on how we can secure our keys. So in connection with the passphrase and the key that is properly utilized, we can extract that data. And we touched on the trust model. Of course, we can decrypt only content if the key is assigned a certain trust level. Okay, let's break this down a little bit on the actual commands that we're executing. You can utilize a GUI to create your keys. For example, on the Windows platform, Cleopatra, or on the Mac OS side, we have the GPG suite. Different OSs have GUIs on how you can create this with a user-friendly interface. However, in this scenario, in this training, we focus on automation, trying to get everything done in an automated fashion, utilizing APIs and command line to repeat that process and to be able to scale and to have a life cycle for these different keys. And so I show you here the different keys, the different commands that are being executed, and you can do the same thing with the GUI. This will be covered in a different video. So first step would be, well, we need to create a key. We need to have a key ring system. If you do this the very first time, where there is no key ring system, it will tell you, hey, you know what, let's create a secure database where we can store the keys. And so that will be when we have the generate key command being executed. And guess what? We have two types of keys that we need to generate. We have the public as well as the private keys, so are different commands that will be executed. And we want to take the keys that we have and store them in the file so that we can share them with our partners, with a different Control M agent or with the external resource, depending on what they need to do. So we want to save these GPG keys in an external system. And you can see here in the commands that are being executed, there is this GPG and then parameter with list keys and list secret keys. This is where you can see the difference between the public key and the secret key. If you're using the operation list keys, you get, guess what? all the public keys. And if you want to see if you have private keys in your database or in your key ring, this is where you use list secret keys. And then there are different add-on capabilities in the command that allows us to extract the data and format it in a certain way. So first step, we created the key, we saved the key in the file. Now let's get over to the next step, which is copy this file over to the target platform, and there we need to import it. And so we focus on two different agents in our demo environment. One agent is only responsible for decrypting content, and another agent is only responsible for encrypting content. This is only for educational purposes. In production, you might have these two operations being handled by the same agent. So just that we can kind of simulate here the different keys and how they're being executed, we separated that out. So first step would be, let's import the key into the public, into the right key ring of the agent. And again, remember, run as account and OS account, they have to match with each other. So we import the public key to the agent that is running our decryption process, and we import the private key to the agent that is running the encryption process. Once the key is imported, keep in mind, without a trust, not doing anything. So you need to make sure that you assign the proper trust for the key that you imported. Now we have that key imported in the right system. Now we're taking a look at the encryption. The first one that you see here, the GPG command, is when you do this on command line. And if we translate this from a command line into the template that is assigned to the agent, we have a few details here. For example, one of the details is going to be the recipient. The recipient references the key ID or the key name or the key fingerprint, whatever we want to have in here in the key ring, so that we can extract the right key details. So that is where we have a match of whatever your key is with our template in here. In our demo scenario, our recipient is MFT user, and the sample that I have that is going to being used later is MFT user at trybmc.local. You can use an email address or a recipient that looks like an email address. You can just have a text in there. It doesn't really matter how you define the recipient. This is just a label for that particular key that is going to be used. Next, we have in the encryption attribute something very interesting. Of course, we need to run this in batch mode, which means it can be run by a shell script under the cover. And then we added a piece here called the --armor, which is we want to ASCII armor the content, not just have the file in encrypted fashion on the file system, and we have some weird characters in there. So when you look at the file, you get beeps and all kinds of stuff on your screen. So adding the armor capability here to our GPG command turns it into an ASCII content, which can be read by a text editor like Vim, or you can cat it, or whatever you like to do. And then, of course, we have here the recipient and the output and the encryption variables, so you can specify how the encryption command is going to be executed. We don't need to have a passphrase, really, really important. Encryption does not require a passphrase, so we don't have to add this error as a parameter. Which brings us to the next step, which is now we want to execute the decryption side of the house. So we need to have a GPG template that is assigned to our agents that can decrypt the content. And again, we need to have the information about the recipient, so that matches our key that we have in our key ring. And then from an execution perspective, now we see here we add the passphrase, and the passphrase is stored with our template. You see this up higher here when we create this with jobs as code. Now we have the passphrase in here. Currently, you cannot use CTM secrets in that case, maybe in the future. So currently, you need to have the passphrase in your JSON, or when you create it via the GUI, you need to type in the passphrase. Now, here's something very specific. The way the whole utility works under the cover, we told it, well, you need to run it in batch mode, which means from a shell perspective, from a scripting perspective, we can automate this. But passwords in shell scripts, ooh, that's always hiccup, right? No matter what API you're using, piping in passwords into your application is always a challenge. So for GPG, it was a challenge as well. So there's a thing called pin entry mode loopback. This is really important. I utilize this in the scenarios to pipe the password phrase into the command line utilities with all the other parameters in a proper way, so that it can be used in batch or in shell scripting mode. Really important that you have this in here. If you don't put pin entry mode in there, then it thinks that you are in interactive mode and were going to type in the password. And of course, as Control M agent is running this under the cover, there's no human interaction. So we need to make sure that the GPG utility is properly automated. Okay. We have this now configured. We have our agents out there. We have the keys deployed. Now we need to make sure that the agent as well as the connection profiles are properly configured. So you see here a few API commands for jobs as code that we are utilizing here, or that we are using really to drive the automation of this whole process. Configure the agent, the GPG/the PGP template properly, and you see here there's a get, an add, delete, and an update capability that we provide via the API. In some cases, if the template already exists, then all I need to do is maybe update the passphrase or other components, or I just want to delete it and recreate this, so you are very flexible with this. And from a connection profile perspective, I make it also very simple to automate the whole life cycle, which means I go out to Control M and I figure out which of my agents have MFT installed. So you can look here at the type file transfer. So that's what we want to deploy, a connection profile of file transfer, and bring this out. And we can use this to analyze and really automate the lifecycle. And again, this portion of how do I automate this and make this as a lifecycle, generating the keys, deploying the keys, and then keep this up to date and make this work, is something that we cover in the different videos. But all the artifacts, so to speak, that we need to have to make this work are here. So let's summarize a little bit on what we need to do in order to get this working properly. Well, we need to have first a GPG key ring, and we need to create the proper keys, private key, public key, and to keep in mind they are tied to the OS user because it's really created for that particular user, and our connection profile needs to reference this particular OS user. So we created the key, we deploy the key to the different agents, and making sure that the mapping between connection profile and the user is properly set. So that would be our deployment of just the GPG core infrastructure. Once the infrastructure in air quotes is properly handled, then we need to make sure that we have a connection profile with local file system access and the proper run as user. And the second one, we have a GPG template that is tied to the agent. GPG templates cannot be like connection profile distributed across all the agents, right? That's not the concept. The concept is that you have a GPG template tied to an agent, and each of these agents can execute it in a different way. And this is what you define in the template and utilize different variables. And so that is really tied to an agent and therefore must be associated to an agent. So these are the multiple steps that we have to just get our GPG properly configured. And once this is done, then we can have an MFT job that focuses on encrypting a data using the public key, moving that file over to an SFTP or an AWS S3 bucket or any other cloud storage that you want to have, and then take this data from an SFTP or cloud storage and pull this file down and get it onto the local file system. So every time we're hitting the local file system, we can really invoke the GPG operations. So that would be the summary of the different steps and activities that we have to perform. Now, the next portion of the video, we will concentrate on executing what we just discussed and see this in action. Okay, let's get started. We have multiple agents available. Now we need to identify which agent we are going to use for the encryption and which one for the decryption. And in order to achieve this, let's take a look at our configuration. We have multiple agents available, and in the flow itself, we are using host groups assignment. So agent 1 is going to be our enterprise manager. This one is responsible for encrypting the content. Therefore, this agent needs to have only the public key. And agent 2 is on the gateway machine here. This one is going to be the one decrypting the content. Therefore, it needs to have the private key and the passphrase. Okay, so we have identified the two different machines. Let's go back here and open up Enterprise Manager as well as the gateway. There we are. Who are we on that machine? As we can see here, we are the MFT user that is assigned to us. And the first thing that we are going to check, just to make sure that we do not have any existing keys, we're going to execute two commands. One is to list the public key and one is to list the private key. As you can see here, list keys as well as list secret keys return with no key on this machine. And let's take a look here. On this machine, we are also in the clear. So far, so good. No keys in our key ring, which also means that the key ring is properly initialized. Otherwise, we would have gotten a message that it will create the key ring for us. So the first thing that we want to really work on is creating our key. And again, I put all these commands in the script. Generate key. We use an email address and save the output of our public and private key into this folder. You see the individual GPG commands that will be generated, and then we're going to highlight a few things. So first of all, our key name here looks like the email address of the user, which is great. We have the passphrase printed out, and keep in mind this is for education purposes only, and therefore we delete that account later, so that's okay that we print that. We have the key ID in here as well, and we talked about the key ID and what it means and how we can benefit for this in future use cases. But all the information that we have is stored in a JSON file, this particular JSON file. So why don't we have a look at this one with JQ, and we are going to take a look in this folder, and then the JSON file is going to be this one here. And there we see we have the name of our key, the public and the private, as well as the passphrase. Again, this is for automation and education purposes that we save that information in production. Of course, you would do that a little bit different. But an interesting piece is we save the private and the public key into an ASCII armored file. You see that at the end, ASC file name. So let's take a look at this as well. Let's take a look at the public key here, because that's the one that we're going to use on this machine. And you can see here, this is the public key in ASCII armored, which means human and machine readable text. Makes it easy to consume. Now keep in mind, we generated the keys and the files via the command line utility. If you are using Cleopatra on the Windows platform or GPG Suite on Mac or on Linux, you would have then a GUI-driven approach, but at the end of the day, you generate these two files that we are going to deploy. So far, so good. We have the keys, we have the files. So the next piece that we need to look into, we need to we need to import the keys into the respective agents. And so for this one, we do the same thing. We need to import the key into our environment, and therefore we're going to put this here properly together. Okay, so Again, we have an import script, and in this case we are importing the public key on the machine that is on agent 1 or host group agent 1, which is our enterprise manager, because this is the machine responsible for encrypting our content. So we see that this here is now our public key imported, and as we can see here, we have a few details that we found in that file. Was the file name for the public and the private key we imported. Here's the key name, the key ID. The import was successful, so our status is true. If the key exists already, or if there are any issues with the key, then the script would print out false. So we see the public key is properly imported in our enterprise manager. Gateway machine, we need to do the same thing, but in this case we need to import the private key, because private key is what we need for decryption. And we put this in the script as well. Import the private key. And now we see here the section of the public key is empty and the section of the private key has some data. Our import was successful. Here is the key ID in the file, and here is the key ID in our key ring. They both match. They should. They better match, because that's the key ID that we referenced to earlier. So if we take a look, this is the private key ID, and if we switch over to the other machine, here we have the public key ID. Because it's the same key, they both have the same ID. It is just one time we use the private portion, one time we use the public portion to properly encrypt our content. So the first stage is covered. We generated the key, we put it on the right machine, we put it in the right user ID that the agent and the flows will later utilize. So all we have to do now is take a look at our PGP template and our local connection profile. So let's go back to configuration. Let's take a look at the connection profiles. First, we have here centralized connection profiles. This one here is a local connection profile. Let's take a look at this one. We have here as the run as user. Remember, we touched on this one earlier. This one is MFT user. This is the same that we using right now to create and to import the keys. So really important. So let's test our login on these two machines. This is on the gateway machine. We can successfully authenticate, and this is the enterprise manager. We can also here, as you can see, successfully authenticate. Why do we have this separated? We have this separated because we want to have anything that is related with encryption and decryption in a separate user account and not the agent account. This way we have some segregation of duties and access of these resources. Okay, we tested this one. Next we go over and take a look at our agent, but this time from a PGP template perspective. So we need to go into the plugin, and we identified already two agents that we are running. So just for fun, let's take a look at the first one agent. We are not going to use this one, but under configuration, we're going to take a look at the PGP templates. And guess what? We have no PGP templates on this machine. Then let's take a look at our gateway. PGP templates is empty. And we would expect the same thing on our enterprise manager. This one is empty as well. So that means we need to deploy the PGP template with the proper settings. Okay, let's go back here and run the script to deploy. Now here's the nice part. We can run this script to deploy on any of these two machines because our files that we use for the deployment are on an NFS share. So just made it a little bit simpler. So we deployed it to the first agent. You see the CTM API is active. It is evaluating what servers do I have, what agents do I have, and we can deploy this now against all the agents that we have, or we can specify we want to deploy this only against one agent. So let's run the same command one more time, but in this case is the second agent that we have. This is our gateway agent. Again, here the same information is being pulled in from the environment, and we are going to create the PGP template. First, you can see here the PGP template get is used to check if we already have a template. If we had one, we had to either delete it or update it, and this one makes it very flexible. Also really nice, let's take a look on how the template looks like. You see here, this is the JSON of our template for jobs as code. So let's take a look with JQ on what we have in this template. And here we have the different settings that we already touched on before. Just to recap, we have our passphrase in here that we need for decryption. We have our recipient, and I talked about this earlier. This recipient looks like the email address because this is what we are going to use in our private and public key, so make that easy to use. Another interesting aspect is you see here the name of our template has ZZM in front, and then I opted to use the key ID in order to have this in the template. Makes it easy for me to administrate later down the road because I can automate the lifecycle of this key. And here's a limitation of Control M configuration for MFT. The start of these cannot be in numbers, so therefore I put a prefix of ZZM, make sure that it's always this template name. So let's go and let's have a look at the actual template. So we deployed this against the gateway machine. Again, if I go in here and check template management, all of a sudden we see here our ZZM template, the recipient with that email looking name. The passphrase, of course, is encrypted, will not be shown. And then we have our encryption and decryption parameter. In addition, you can see also which PGP command we are going to execute since we are using open GPG. That is going to be the binary. This is deployed on this agent. Let's double check on the enterprise manager. We expect the same thing to be there. Here we see our ZZM, and because we deployed it only against one agent, this agent here will have no ZZM PGP template. Great. So we have two agents. They both have the template. They both have the keys properly deployed and configured. So all we have to do is run a folder. Okay. So let's take a look at executing a folder. Needs to go this way. So here we have a example folder that first focuses on decrypting a file. We create a test file with ASCII values in there. We generate or we check the fingerprint of this file. Then we do the transfer with the GPG decryption. So let's take a look at this operation here really quick. In the general section, here's our file name, from where to where we sent this file over. This is our temporary file. And in the advanced section, we specify, yes, ignore this one, we specify under commands that we want to execute the PGP. And I'm using here the GPG template name as a variable, so not hard coding this in one. And I'm enforcing the operations because we are going from local to local or from local to SFTP, whichever. I can specify which operation I want to have. So here in this case, we want to have the encryption of this. And you see here, this one here from the browser a little bit in the bottom, keep encrypted files. It is checked. This is only for education purposes. In production, you might not want to keep these files around. We keep this file around because then we have another fingerprint that we're going to execute and take a look at this file, and more when we get to the actual run of this folder. And then the next subfolder here focuses on encrypting the file. As we mentioned earlier, I always need to have a local file system. So we pulling this file from SFTP to the local file system And then in the advanced section, you can see here in the commands that I'm performing no GPG or PGP operation. How funny is that? Well, here's the point. The reason why I moved the file over as it is because I want to execute another fingerprint for education purposes to show that we actually received that file and that there is a fingerprint in there. And then the next step, this is the one where we have the GPG operation and move it from local to local. Click on command, and in this case we do the decrypt, and we do not want to keep the file around. We use the template in here, and now where's the passphrase? Hey, we know for decryption we always need to have the passphrase. Well, remember, our PGP template has the passphrase, so we don't need to expose this, which means we can decouple the GPG utilization or usage, or we can hand this over to an end user, a power user of Control M. They don't need to know the passphrase. They have no access to this. All they do is, I'm utilizing this connection profile, I'm utilizing this particular PGP template, and all the credentials are hidden from the user. Cool. So now let's run this one. We check this one in because I checked it out to go into the details easier and run this flow. Yes. Okay, go into our monitoring domain and our capability demos. And here we have the latest run. It's running here. It created the temporary file. So let's move this over a little bit. We make this smaller because we'll take a look at this later. Okay, so the first step was running. Let's take a look. This was creating our temporary file. Here we have the file name, a text file that contains all letters of the alphabet, and then we are going to use this file and encrypt the file. And so here, look at this one. First thing, we encounter an error. Oh my goodness, what happened? Why is it not working? Okay, let's analyze this a little bit. We have the file. It is in this folder here. This is our temporary file that we generate. It is trying to retrieve this file. So someone could wonder, do I have no access to the file system, or what's going on here? But then look at the bottom, look at the next line in here. Failed to copy the file over. The template that we want to execute doesn't exist. So we assigned in the folder a variable, and therefore this one here, that is the actual template, it doesn't exist. So now we have to go back to our planning domain and make sure that we have the right template name in here. Okay, so here in the top under general we see all the variables that we are using, and the first one here is the name of the GPG template that we deployed. Okay, so this is the one that we had running in the past. So let's take a look on the template name that it was before. Actually, if we go back to our script here, where did I have this one? Oh, that was in here. I make this, minimize this one, go up here. Here is our template name there. So we're going to use this one. This is the new template name, and we copy this one over into our folder. So delete this one. This is invalid. And this is the new one. So this was troubleshooting step number 1, making sure that we have the right template in there. And then we have a few more troubleshooting steps as we execute this. So let's run this one more time. Now we have the right template in here. Okay, go to our monitoring domain. We leave this one, we minimize this, and let's refresh it here really quick. And here is our folder.
And there it is. So it's running. First step was here, do the transfer. Let's take a look. Transfer was successful, and we see here the su command that was executing, encrypting this file. And I hope you can appreciate what we touched on earlier, that it must be the run as user in the connection profile must match our GPG environment with the proper keys, because you see here we do an SU in this particular user account, and then we are executing the GPG command with all the parameters that we assigned in the template. And one of them was to do this in ASCII armor so that we can read this later. Here's our encryption. So this whole string here that you can see on this line is the one that is being executed by the run as user. If for some reason this one returns an error, you can just copy and paste this, go over to your SSH session into the agent that you're in and execute this and see what the operating system will bring back, what kind of error message it will bring back. So next we uploaded the file. Actually, remember we kept the PGP file because we are running here a fingerprint, and fingerprint means we're going to check what kind of key was used to encrypt the file. And we have here the key ID that was used for encrypting that content. And we can also go back to our fingerprint before, and this script will try to figure out, hey, is this an encrypted file? And you see this is our file here, the text file, but GPG status is false because that's still the file in clear text. So at this point, this file is in clear text, no encryption takes place. Then our MFT job is encrypting the file. Then we do another fingerprint of the temp file that we kept, just to make sure. And you see here the temp name has the extension .pgp_aft. Just identify that this is the one that is being moved over to the target system. Now that we move it over to the target system, we want to check on the target system. Yeah, great, I have this text file over on the other side, but did I receive the one that was actually encrypted, or did I receive the one that was decrypted? And you see here the fingerprint that we're executing is telling me, yes, this is an encrypted file and it is ASCII armored, which means it could be printed. There are only ASCII characters in there. Next step that we're performing is to decrypt the file. And now this is a little bit more interesting here, because remember, for decryption, we need to have the proper private key in place. We need to have the passphrase in place. And so here the MFT user is going to execute the GPG command, and it's providing the passphrase. And because we handed over pin entry mode loopback, means that the passphrase is being handed over to the command line utility via a batch script. Then we have a few more details. We see here what is the public key that was used to encrypt the file. We get some more key details about here. You can see here, this one here is our recipient. Oh, and look at this. That looks like our email for the user. So if you use the recipient name like the email address, then it's easier to manage this if you have hundreds of different keys. Otherwise, you have to figure out what's the best way to create the different keys and manage them. And so this one was successful. It extracted, or better, it decrypted the file. And the last step in here is when we do the cleanup. Here what I'm doing is I'm just printing out the last two lines in that file. And we can see here, this is the timestamp, and this is every letter of the alphabet, and this is every number that we know right now. Of course, there are no German umlaute here, so only the English letter of the alphabet. No special characters, no Spanish letters either, or other characters in that text. So this is just a simple test to make this work. So great. We looked at the decryption and encryption of this, and there is just one more thing that we need to watch out for to make sure that our process is running. And for this reason, I have this flow here that I was running much earlier, and I wanted to highlight something that we can see in the system output. And so let me see, is it this one here? Okay, this is the same one. We didn't have the template, so we covered this already. Then we have the second error, which is this one here. Oh yeah, this is the one. Okay, so keep in mind, we touched on PGP template doesn't exist. That could throw up an error. You might have deployed the PGP template to the wrong agent. Remember, templates are bound to an agent, not like centralized connection profiles. But here is another little thing that we can see. You see here the output is using a temporary directory, the PGP temp. And this is under the agent install. So my user account for the agent is called CTMAG. Then we have the control M in subdirectory and the CMs. In this case, our MFT CM, which is here the folder called AFT. And there is a temp directory for anything that is PGP related. Now, we know that we are not executing the command in the context of the agent, which is CTMAG. We are running it in the context of, guess who? It was our MFT user. You see this here? There is MFT user. So now the question is, why can I not get there? The command is failing. So an easy thing for you to do is just copy and paste this whole string here and execute this on your shell directly and see what happens. But let's save on this one for the demo purposes and directly go into the issue. So the issue is that this is the directory managed by the CTMAG user ID on the operating system, and the user ID MFT user has no permission in that temp folder. It cannot write the temp file in there. This is why PGP is failing. Now, you have two choices here. You can either open up this directory to the MFT user and say, you have now write permission in this directory. You want to be careful with this because this is sensitive data that we're handling with. Do we want to have this in there or not? This is your decision. But in order to have an alternative to this, let's take a look at our configuration of the MFT CM itself. And for this reason, we go here into the CM, take a look at our plugin configuration, and there we have now the first agent. And let's take a look at configuration. And this time we don't need to go into template management because template is right. We configured this, we have the name in the folder. But when we take a look at the client configuration, you see there is a PGP temporary folder, and this one out of the box points to the agent location. So if we are using PGP with the agent account, nothing needs to be changed. That works just fine. Now, for our gateway and for our EM machine, let's go and take a look there in the client configuration. This is where we change this. So this is a dedicated temporary folder where the MFT user account has all the permissions and nobody else. This way we add an additional security for any temporary files. Let's say the agent is being killed by someone and the PGP process was running at that time, and you want to prevent anybody but the MFT user having access to that file. And this is why we can put this in its own directory. So the reason why the two jobs or this one job failed earlier was because it didn't have write access, and so we changed the directory structure in here. And that concludes this portion of the demo. In the next one, we will touch on a few more lifecycle activities on how can we automate the deployment, how can we make sure that we don't have to use one template definition per folder. When we take a look in here, I variabilized the PGP template name. So how can we utilize the fingerprint capability or the ID of the key that being used and streamline that process of assigning the right key and making the administrative load easier.
Okay, so now that we have finished that piece of our demonstration, let's take a look again on what we have done. We created the GPG key, the public and the private key. We deployed the key to two different agents. Agent 1 for the encryption that has the public key, agent 2 with the private key to focus on the decryption process. We created centralized connection profiles that have access to the local file system, and because it's a centralized connection profile and we have both users have the same MFT user on the operating system, we need only one centralized connection profile. That makes it easy, that we made that easy here. And then we deployed the template to the two different agents. The template had both the same settings to make that easy for us, yet we are utilizing on one agent only the decryption and on the other agent only the encryption. And then we executed the jobs that we have in here. So if we summarize today's session, we focused on data privacy. This is beyond just having a secure transfer of the data, but we want to make sure that the data at rest is also secure. So for this reason, we implemented GPG with the key ring, and we configured Control M properly from an agent as well as from a connection profile perspective, made sure that the infrastructure of Control M is properly set up for GPG. And then on top of this, we build content to demonstrate the decryption and encryption phase. I hope that video was helpful for you. Put some notes in and comment if you like, and we will have another session that focuses on the life cycle of this, as well as a video that showcases the GUI creation of that content and how we would accommodate that. Thank you so much for your participation, or actually for your attention watching that video. See you next time. Bye.